Okay, so for problem 2, we want f of x to equal -3, so let's just set them equal to each other. Okay, so I would like to use the quadratic formula, so I'm going to add 3 to both sides so that this side becomes 0. Yeah, I could also check if this is factorable, but I'm going to go straight into the quadratic formula. Right, so a is 6, b is 8, c is -22. So notice you do need to get the 0 on the other side first before doing the quadratic formula. If you had done the quadratic formula up here, you would have thought that c was -25, which it clearly isn't. Okay, so x equals -b plus or minus b squared minus 4 times a times c all over 2 times a. Let's see. -4 times 6 times -22 is positive 528. Uh, 64 plus 528 is 592. Okay, so can I simplify this radical at all? So 592. So what are some perfect squares? 2 squared is 4, 3 squared is 9, 4 squared is 16. So I can just do guess and check if I want. I can just see which of these divides evenly. I could also do prime factorization to more directly see what the, if any factors squared are there. Okay, but it turns out that 592 is equal to 16 times 37. So 16 is 4 squared, so we can make this 4 radical 37. Okay, so in this case, all 3 terms are divisible by 4. The -8, the 4 radical 37, and the 12. So I'm going to divide everything by 4. So 4 radical 37 divided by 4 is 1 radical 37, or just radical 37. Okay, so there would be the answer to problem 2. Okay, let's do problem 5. So I want 2x squared plus 7 to be greater than 9x. Okay, so let's get everything to the same side. Okay, so we could do quadratic formula. Well, again, I'm going to temporarily pretend this is an equation just to find the key values. So this one is factorable, though. Okay, so using the zero product property, either 2x minus 7 equals 0 or x minus 1 equals 0. Okay, so the two key values here are 7/2 and positive 1. Okay, so if I were to sketch those on a coordinate plane, I've got 1 and I've got 7/2, which is 3.5. Okay, so for my inequality, the a value is positive 2, so that means this parabola opens up. So I need to sketch a parabola that opens upward and goes through the two key values. Okay, and then now which part of the parabola do I want? So I want the function to be greater than 0. So here is 0, so I want the sections above 0. Okay, so that means from negative infinity up to 1, but not including 1 because the inequality does not have the or equal to, and union because we have a gap, and then starting up again at 3.5 all the way to infinity. Okay, moving on. Problem 8. So I want f of x to equal 29. Okay, so in this case, the absolute value symbol is already by itself on this side of the equal sign, so I can move to the plus minus step. And now I split it into two equations, one positive, one negative. So here's the positive version. It's essentially unchanged. And then the negative version, I need to keep the parentheses. Okay, so over on the positive version, subtract 1 from both sides. And then divide both sides by -5. Okay, so one answer is -28/5. Let's solve the other one. Remember, we do need to distribute this minus sign out. So -1 and negative times -5x is plus 5x. Okay, so the two solutions are x could be -28/5, and it can also be 6. Okay, let's do 10. So I want f of x to be less than or equal to 60. So again, the absolute value is already by itself, so I don't need to do anything yet. So I'm going to temporarily pretend it's an equation and replace the absolute value with plus or minus. Okay, so the plus version would look like this. The minus version would look like this. Okay, so over here, x is -10. Over here, when you distribute it out, -6x is positive 6x. Okay, so the two important values in this problem are -10 and positive 10. So I'm going to draw a sketch over here. Okay, so again, the absolute value is opening upward because the a value is the invisible positive 1. So I'm going to draw an upward opening V. And I want the absolute value to be less than or equal to the constant. So anytime the variable is less than the constant, I shade in below the horizontal line. Okay, so that means that the section I want starts at -10 and including -10 because the or equal to. And I continue on to positive 10. Okay, I'll do 11 also. Oops, sorry, minus. Okay, so this time, first step, I want to get the absolute value by itself. So I want to get rid of this plus 22. Okay, so at this point, I've got the absolute value by itself already. So instead of jumping to what I did over here, let's think about this graph. So hopefully we remember the absolute value vertex is at h comma k. So the vertex here would be at 8, 0. And because a is positive, the graph will open upward. Okay, and we want all the values of x where the value is greater than negative 12. But we can see in our sketch that the graph will never get even close to negative 12. It will always be above it. So, right, for the entire graph, no matter how far right or left you go, every single value is above negative 12. Okay, so again, whenever you get the absolute value by itself, just stop and look at the inequality and see if it will always be true or sometimes it will never be true. Okay, and for a word problem, I'll do problem 14. Okay, so the profits are represented by this quadratic. So the important thing to note is that the A value is negative. So I know that means it will open downward in some way. Okay, so I want to know when will his business have the maximum profit. So for a downward opening parabola, the maximum profit would happen at the vertex. Okay, but we want to consider our input and output. So T is the time, and P of T is the profit. So when they ask me for the profit, I need the Y value of the vertex. Okay, so I can either do vertex form or I can do the axis of symmetry. So maybe I'll do the axis of symmetry formula. Oh, actually, it's not X in this problem, it's T. Okay, so B is 18, so negative 18 over 2 times A, which is negative 3. Okay, so the time of the vertex will be after 3 years. And that's actually what they asked for, right? Because they didn't ask us yet what the maximum profit is, just when that will happen. Okay, now for part B, this is where they do ask what is the maximum profit. So what is the Y value of the vertex? So if you already know the X value, you can just substitute it in. Okay, so 23, but keep in mind the units are hundreds of thousands of dollars. So $2,300,000. Okay, so that would be right, because this is 2,300, and then you want 1,000 of those. Okay, and then lastly, at what time will it be too late? Meaning, when will he start losing money? So he will start losing money right after the profits go below 0. Right, so we need to figure out at what time does his profit hit 0, and then we can find what's after that. Okay, so we got to find where the function equals 0. Okay, so this one does not look factorable, so I'm going to do the quadratic formula. Okay, so can square root of 276 be simplified? So maybe I'll do a factor tree this time. 2 times 138, 2 times 69, 3 times 23. Okay, so there's a 2 squared hidden in there. So 276 is equal to 2 radical 69. Okay, so for a word problem, it's probably more understandable if we just do a decimal approximation. So why don't I just do that? So first I'll do the plus. Okay, so the plus version is 0.23 approximately, and the minus version is about 5.77. Okay, so looking at our graph, so it actually looks like both points are in the positives. So it says the situation is he realizes his company is on the downturn. So we're not looking at this one, we're looking at this one. So the greater value. So it would be about 5.77 years then.